Today I'm going to try and show you how to do a simple student's t-test. What a t-test is a comparison of two sets of data, and we're going to try and find out if there's a significant difference between those two sets. Now typically what people do is they'll just do a mean and a standard deviation and try and see if that shows a difference, but the t-test is going to be more involved. It's actually going to involve finding the number of items that you have down here and the variance. I've already set up here two sets of data, which I've arbitrarily called set A and set B. I'll show you the number of items at each one, so we'll say count. The Excel formula for the number of items is simply count. So you can see that in that first one there, we have 7 items, and in this second set, we have 5 items. So we have 12 items total here. Let's just put that down here so we all know we have 12. I also want to just show you simply how you do statistics here. Let's go ahead and figure out what the average is of each set. And the formula for average, of course, is just average in Excel. Let's put that down here so we have 123 for the average of the first one. And in the second set here, you have an average of 124. Pretty close. So just looking at those two sets right away, if that's all I was doing, I might say they look pretty much the same. Let's also take a look at what the standard deviation is. Formula for standard deviation in Excel is STDEV equals STDEV. Let's drag over those same numbers. 19.5. And over here we have a standard deviation for these guys. Oops, too many here. Of 15.3. So far, set A would be defined as 123 plus or minus 19, and set B would be defined as 124 plus or minus 15. I'm just going to clear that up by adjusting the cells here to no decimals so we all know what I'm talking about. If that was all I was going to do on the statistics, I might say that those two sets really had no difference. Okay, here's how we're going to do it. We're going to start off with a null hypothesis. What is a null hypothesis? Well, there's a couple of ways of looking at it. First way is a null hypothesis means there's no significant difference between the two sets. Another way to do it is a null hypothesis tells you mathematically what you can expect. In this case, if I said there's no difference between the two sets, mathematically I could say that set B should have pretty much the same average as set A. That is 123. Mathematically, I can go ahead and do that. Now we're going to do something more involved than that to prove if the null hypothesis is true or not by doing a t-test. Here's how you do it. I'm going to go ahead and put equals in here, and I'm going to insert in a function. Now the function is going to be statistical, so I've already got that, and the statistical calculation is going to be the t-test. There it is right down here. Now the t-test is going to require us to give 4 pieces of information. The first is array number 1. Array number 1 is simply your first set of data. Let's use the finder over here. We'll browse on over here and select that first set, which is B2 to B8. Array number 2 is going to be the second set of data. There it is right there, C2 through C6. Doesn't matter, by the way, that the two sets are unequal in the number of items that they have. Now the last two things it's going to ask us for is tails. Now, if you look down here, it specifies the number of distribution tails to return, 1 or 2. So imagine we went ahead and plotted all this data. Hopefully, it should look like a bell curve in a normal distribution. The two ends of the bell curve are going to be the tails, right and left. Those are the extremes. If you know that set B would be moved in one direction, you would use a one-tail test. Now, we don't know that. We don't know if the average is going to go up or down in this particular test. So the default is we'll just use both ends of the distribution. Last thing we need to do is type. You can do 1, 2, or 3. If you had paired data, you do 1. Now, paired data means that each piece of data is changing and can be corresponding to itself. Let's suppose that I had 10 chickens and I give them a diet, and I look at the number of eggs they lay. Each chicken on and off the diet could be compared to itself. That's not the case in this sample. So in this sample, we wouldn't use 1. It's unpaired, or what we would call independent sampling. And since the numbers are different, we have 7 items and 5 items, it's an unequal variance, so our default is pretty much going to be 3. We will pretty much use 2 tails and type 3 for the tests we use in most biological tests. Let's press OK. This then gives us a value of 0.95. I'm going to clean that up here. Let's just reduce that down to 2 decimals. So I get a t-value of 0.96. Very good. Now what do we go ahead and do with that? Well, the last thing you need to do is take that value of 0.96 and take it to a t-table and see what is the probability that your null hypothesis is accepted or rejected. Last thing we need to do before we go to that t-table is figure out degrees of freedom. Now, degrees of freedom means statistically how many combinations you could make here. It's very simple to do it. If you had one set of data, you take the count and you subtract 1. So if I was just using set A and I had 7 items here, 7 minus 1 would give me degrees of freedom 6. However, in this t-test, I have 2 sets of data. The total number is 12 items. So instead of taking 12 minus 1, I go 12 minus 2, and I get degrees of freedom 10. Here's the values I need to use then. The t-value, critical value, is 0.96. Degrees of freedom is 10. Let's go ahead and take those values to a t-table and see where they line up. Here's a simple t-table that I got from a internet site. We're going to look down here where it says the number of degree freedom is 10. And on ours we got 0.96. Where is 0.96? 0.96 flows somewhere in between 0.69 here and 1.37, right in the middle. So if you look on up here, then the probability would be between 0.10 and 0.25. 0.10 and 0.25. That means what is the likelihood that the null hypothesis is true or false? Typically, we use 0.05 for the deciding value in biological assays. That is, if it's less than 0.05 down in this area here, we would say that we have to reject it. If it's above 0.05, we would say we'd have to accept it. So in this case, since our value would bring us up between 0.1 and 0.25, we would say we have to accept it. One last thing here. That's if you're doing a one-tail test. See up here it has a binomial distribution for a one-tail test. To do a two-tail test, all you have to do is simply divide these guys. So instead of saying our value fell between 0.10 and 0.25, you would say that it really fell between 0.05 and 0.125, which still meets our 0.05 critical value, and we would have to say that the null hypothesis is going to be accepted.